I am Rajalakshmi, working as an assistant professor in the Department of ECE at R.M.K College of Engineering and Technology. This video is all about the quality assurance. Quality may be considered throughout the design process to ensure high quality design. The quality of a product or service can be judged by how well it satisfies its intended function. There are several reasons why the product quality goes low. The first reason may be the product may be poorly manufactured, the components may be improperly designed, the architecture was poorly conceived, the product's requirements were poorly understood. The quality assurance process is vital for the delivery of a satisfactory system. In this section, we will concentrate on portions of the methodology particularly aimed at improving the quality of the resulting system. If the system is too difficult to design, it will probably be difficult to keep it working properly. To help you understand the importance of quality assurance, I will tell you a serious safety problem in one computer-controlled medical system. In the year 1986, we have a radiotherapy system named as THERAC-25 for treating cancer. The image shows the THERAC-25. It consists of a bed and a beam emitter which was placed over the site of the tumor. On March 21, 1986, a male cancer patient received radiotherapy treatment for a small tumor on his back from a new type of radiotherapy machine, the THERAC-25. The patient had been prescribed a small dosage of 120 radians. When it was turned on, the THERAC began buzzing loudly. The patient felt a horrific flash of pain, and the skin on his back began to sizzle. He had received a massive overdose of radiation. Instead of 180 rads, he received tens of thousands of rads. He was immediately given treatment for radiation sickness, but it was too late. The patient passed away 5 months later. The THERAC-25 incident is used as a cautionary tale of how poorly designed computerized medical devices can cause catastrophic consequences. This THERAC-25 disaster is considered as a worldwide software bug engineering disaster. Hope this example makes you understand why quality assurance is important in embedded system. So in this section, we review the quality assurance process in more detail. So coming to the quality assurance technique, we have ISO 9000. So ISO 9000 is an international standard organization. So it was developed by the International Standard Organization, which has been created a set of quality standards known as ISO 9000. So ISO 9000 was created to apply to a broad range of industries, but not limited to embedded hardware and software. The focus of ISO 9000 is to concentrate on process used to create the product or service. The processes used to satisfy ISO 9000 affect the entire organization as well as the individual steps taken during design and manufacturing. There are some observations based on ISO 9000. The first observation is that the process is crucial. So knowing what steps are to be followed to create a high quality product is essential to ensure that all the necessary steps are in fact followed. The next observation is that the documentation is important. So documentation has several roles. The creation of the document describing the processes helped all those involved to understand the process. So documentation helps internal quality monitoring groups to ensure that the required processes are actually being followed. Documentation also helps outside groups to understand the process and how they are being implemented. Good documentation is an aid for helping people understand the total quality process. The last observation is that communication is important. The people in the organization should understand not only their specific tasks but also how their jobs can affect the overall system quality. So many types of techniques can be used to verify the system designs and quality ensure. The techniques can be either manual or tool based. The manual techniques are surprisingly effective in practice. Most of the software testing techniques can be applied manually by tracing through the program to determine the required test. Tool-based verification helps considerably in managing large quantities of information that may be generated in a complex design. Coming to the techniques, we have test generation programs, which can automate much of the drudgery of creating test sets for program. Next, we have is tracking tools, which can help ensure that various steps have been performed. The last we have is design flow tools, which can automate the process of running design data through other tools. So metrics are important to the quality control process. To know whether we have achieved high levels of quality, we must be able to measure aspects of the system and our design process. We can measure certain aspects of the system, say execution speed of programs or the coverage of test patterns, or we can also measure the aspects of the design process such as rate at which the bugs are found. So coming to ISO 9000, so the important role of ISO 9000 is to help organizations study their total process, not just particular segments that may appear to be important at a particular time. There is a well-known way to measuring the quality of an organization's software development process is the capability maturity model, which is abbreviated as CMM. The CMM provides a model for judging an organization. The CMM defines 5 levels of maturity. The first level is initial, a poorly organized process with very few well-defined processes. Success of a project depends on the effects of the individuals, not the organization itself. The second level is repeatable. This level provides basic tracking mechanisms that allows management to understand cost, scheduling, and how well the system understand development meet their goals. The third level is defined. In this level, the management and engineering processes are documented and standardized. All projects makes use of documented and approved standard methods. The next level is managed. This phase makes detailed measurements of the development process and product quality. The last level is optimizing. In this level, the highest level, feedback from detailed measurements is used to continuously improve the organization's process. Next, coming to the verifying the specifications. The requirements and specification are generated very early in the design process. So verifying the requirements and specification is very important for the simple reason that bugs in the requirements or specification can be extremely expensive to fix later on. So the figure shows how the cost for fixing the bugs grows over the course of the design process. The longer a bug survives in the system, the more expensive it will be to fix. A coding bug, if not found until after certain system development, will cost money to recall and reprogram existing systems, among other things. But a bug introduced earlier in the flow and not discovered until the same point will occur all the cost and more cost as well. A bug introduced in the requirements or specification and left until maintenance could force an entire redesign of the product. So coming to the requirements validation, because requirements come from the customer and are inherently somewhat informal, it may seem like a challenge to validate them. However, there are many things that can be done to ensure that the customer and the person actually writing the requirements are communicating. Prototypes are a very useful tool when dealing with the end users rather than simply describe the system to them in broad technical terms. A prototype can let them see, hear, and touch at least some of the important aspects of the system. Of course, the prototype will not be fully functional because the design work has not yet been done. However, user interfaces in particular are well suited to prototyping and user testing. So, validation of specification. The techniques used to validate the requirements are also useful in verifying that the specifications are correct. A design review is simply a meeting in which team members discuss a design, reviewing how a component of the system works. The design review is a critical component of any quality assurance process. It is a simple, low-cost way to catch bugs early in the design process. Some bugs are caught simply by preparing for the meeting, as the designer is forced to think through the design in detail. Other bugs are caught by people attending the meeting who will notice problems that may not be caught by the unit's designer. By catching bugs early and not allowing them to propagate into the implementation, we can reduce the time required to get a working system. We can also use the design review to improve the quality of the implementation and make future changes easier to implement. A design review is held to review a particular components of the design. A design review team has several types of member, which includes the designer, who is a person presents their design to the rest of the team for review and analysis. So the review leader is the one who coordinates the pre-meeting activities, the design review itself, and the post-meeting follow-up. The review scribe is responsible for recording the minutes of the meeting so that the designers and others know which problems need to be fixed. The review audience members are the members of the project for which this component is being designed. Audience members from other projects often add valuable perspective and may notice problems that team members have missed. Actually, the design review process begins before the meeting itself. The design team prepares a set of documents which consist of code listings, flowcharts, specifications, and so many that will be used to describe the component. These documents are distributed to other members of the validation of specification so that everyone has time to become familiar with the material. So that's all about the quality assurance process. Thank you.